Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers volume and surface areas. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 13. A cube has edges of length 0.8 meters. Work out the volume in cubic centimeters. Now, they put it in bold there. Just to draw attention to this. It's like a flashing light pointing to it saying, look at me. Okay, it's cubic centimeters and not cubic meters. This is in meters and we want to put it in cubic centimeters. So 0.8 meters, there are 100 centimeters in 1 meter. So 0.8 meters is going to be 100 times 0.8 or 80 centimeters. So that's 80 centimeters by 80 centimeters by 80 centimeters. So to work out the volume of this cube, volume of a cuboid is length times width times height. For a cube, they're all the same. It's going to be 80 times 80 times 80. Tap that into the calculator. 80, oh, I'm just going to use the power button. 80 to the power 3 is 512,000. So that's 512,000 cubic centimeters. 512000. Question 15. This triangle is a cross section of a triangular prism of length 15. So I could, actually it's just like the front face then, isn't it? So if I had like a slice of cheese style prism going on like that, I can draw in an extra dimension maybe to make it a bit clearer. So the triangle is a cross section and the prism is of length 10, so that would be 10 from there to there. Ali writes the volume is going to be 9 times 5 times 10, so the volume is 450 centimeters. Check his working and write the correct solution. Well, he's wrong because what he's doing, he's working out the volume of a cuboid, which is 9 by 5 by 10. That would be 450. This is not a cuboid, it's a triangular face prism. So to work out the area of any prism, you first work out the area of the cross section and then you multiply it by its length. Now the cross section of this shape is not a rectangle, so it's not just 9 times 5, it's actually a triangle, which is half base times height. So the volume of this shape, so volume of a prism, equals cross section times the length, which is a half base height times, well, the length of the prism. And in this case, that's going to be a half times 5 times 9 times 10. Okay, so then typing that into my calculator, 0.5 times 5 times 9 times 10 gives me a volume of 225 centimeters cubed. I just noticed he also got the units wrong, didn't he? So that should be centimeters cubed because it is. Question 21. Eva thinks she can save water by having a shower instead of a bath. Eva's shower uses 10.8 litres per minute and lasts for 8 minutes. Eva assumes that the water in her bath is the shape of this cuboid. So we're given the dimensions of that cuboid, and we're told that 100 centimeters cubed is 1 litre. Using Eva's assumptions, work out how many litres of water she saves by having a shower instead of a bath. Okay, so how much water does she use for the shower? So water used for the shower is going to be 10.8 litres per minute for 8 minutes. So 10.8 times 8. 10.8 times 8, according to my calculator, is 86.4 litres. Okay? Right. Now let's compare that with the amount of water she has in the bath. So she's assumed that the bath is a cuboid with those dimensions. So then the volume of this cuboid is going to be those 3 measurements multiplied together, isn't it? Length, width of height, and times height is the volume of a cuboid. So let's multiply those together. 110 times 50 times 35. What does that come to? So 110 times 50 times 35 gives me 192,500. 192,500. What's the units going to be? Centimeters times centimeters times centimeters. It's going to be cubic centimeters. Now it's time to use this conversion factor here. 1,000 cubic centimeters is 1 litre. So if I've got that in cubic centimeters and I want litres, I need to divide through by 1,000. So, oops. So again, reaching for the calculator, divide by 1,000. I'm going to get 192.5 litres. So that's equal to 192.5 litres. So then the water saved is going to be the difference between those two then, isn't it? It's going to be 192.5, the amount of she's had in the bath, less 86.4. Subtract 86.4. So again, reaching for the calculator, 192.5 minus 86.4. That gives me a total saving of 106.1 litres, which is quite significant, isn't it? So it's less than half as much then. That's definitely a good saving. Okay, and that's assuming, though, her assumptions are correct. This is part A, though. I wonder what part B is going to be. Okay, so part B says A shows the water level before Eva gets into the bath, and B shows the cuboid in the empty bath. What does this tell you about the amount of water saved? So I would say that the cuboid, this is the cross section of the cuboid, isn't it, here? This is the cross section of the cuboid. So that is clearly an underestimation of the water in the bath, because you've got all this extra space around the edge that we haven't accounted for. Okay, so given that we have assumed that the cross section is smaller than it actually is, that's going to be this one here, that's going to be smaller than it actually is. That means that cuboid is going to have a greater volume than it should have, which means that the water saved is going to be even more than that, because this is going to be higher than it was. This is higher than it was, so this is higher than it was, so this is higher than it was. Okay, so she's going to save more water. So what does that tell us about the amount of water saved? It tells us that she has underestimated it. The amount of water saved. Question 11. Joe has a full cup of coffee. She drinks some of it and she says half of the coffee is still in the cup because 5 centimeters is half of 10 centimeters. Is she correct? Now, I am definitely what you would consider to be a cup half full kind of guy, a bit of an optimist. But here, in this case, even though 10 is half of 5, look, the amount of coffee that's in this section here above that 5 centimeter line is going to be much more than the coffee underneath, because it's tapering down, isn't it? So no, she's not right. So tick a box. No. So give me a reason then. So the width of the cup is smaller at the bottom. Question 12 has a water tank which is a cylinder with radius 40 centimeters and depth 150 centimeters. We're told that it's filling at a rate of 0.2 liters per second, and we're being asked, does it take longer than an hour to fill the tank? Well, in order to answer that question, we need to know what the capacity of the cylinder is to start with. So let's do that first. What's the volume of this cylinder? Well, a cylinder is a prism, and the area of a prism is equal to its cross-sectional area times its length, or its height. So we need to work out what this bit is here. Okay, now that area is a circle. It's pi r squared times the height. So the volume of this is going to be, well, that's pi r squared, isn't it? So the volume of this cylinder is going to be pi r squared h. I'll leave the pi in for now. Do I want to leave the pi in? No, let's put it in. 3.14 times 40 squared times 150. So what's that? .14 times 40 times 40 times 150. So that's 753,600. Now that's in cubic centimeters. Now we're told, we should really know this, but 1 litre is 1,000 cubic centimeters. So if it's got a volume of that, then it can hold, let's divide that by 1,000 and find how many litres it can hold. So that's 753.6 litres. Okay, so if it's filled at a rate of 0.2 litres per second, how many seconds does it take to fill up? So time taken to fill up is going to be the volume divided by that flow rate then, isn't it? So taking time is equal to 753.6 divided by 0.2, and that equals 3,768 seconds. 3,768 seconds. Now this question is asking about time in hours, so we need to convert that to hours. So time in hours is going to be the seconds divided by 60 to get minutes, and then another 60 to get hours. So 3,768 divided by 60 divided by 60 is 1.046 reoccurring, which I'm going to round off to 1.05. So that's 1.05 hours. Okay, so does it take longer than 1 hour to fill the tank? Well, yes it does, because it takes 1 hour and 5, or 1 hour at 0.05. So the answer is yes, it takes longer than 1 hour. Question 12. We've been given the volume of a sphere formula, 4/3 pi r cubed, and we're asked to work out the volume of a sphere with the radius 8. Okay, so we just need to sub it into the formula and then work through to an answer. So volume is equal to 4/3 pi times r cubed. We can just type that whole thing straight into the calculator. So 4 divided by 3 times pi times 8 to the power of 3. I make that 2,144 and change, so I'm going to round that up to 2140 cubic centimeters to 3 significant figures. In part B, we have 3 of the same spheres, each again with radius of 8 centimeters, tightly packed into a cuboid box. We need to work out the volume of the cuboid. Now remember that the radius of the sphere is 8, so all the way across is going to be 16, and that then is going to be the height of our cuboid. Similarly, the distance from here to here is also going to be 16 because it's the width of one ball or one sphere. And then this dimension is going to be 3 lots of 16 because I've got 3 balls of width 16 in a row. So then the volume then of the cuboid is length times width times height, which is equal to length of 16, width of 3 times 16 times a height of 16. So 16 times 16 times 16 times 3. And that's 12,288 cubic centimeters. Question 7 has helpfully given us the formula for the volume of a sphere, which is 4/3 pi r cubed. And we're told that a still sphere has a radius of 9 centimeters. So from here to here is 9. Work out the volume of the sphere. So this is just really subbing into that formula. So volume is equal to 4/3 pi r cubed, which is 4/3 of pi times 9 cubed. It's a matter of really typing that into the calculator. So 4 divided by 3 times by pi times by 9 to the power of 3. I make that 3,053 and change. So I'm just going to, I'm going to round off 3053. I'm just going to round off to the nearest whole unit. Which would be 4 then, wouldn't it? In part 7b, we're told that the density of the steel is 7.8 grams per cubic centimeter. Work out the mass of the sphere. Well, density, the formula for density is mass over volume. So rearranging that, so make mass the formula, and mass the subject, sorry, and mass equals, we're going to take this and cross multiply it up here. So mass equals density times volume, which in this case is going to be our 7.8 grams per cubic centimeter multiplied by, just checking the units all the same, yeah, that's in centimeters, so 3054. Now I've still got the stored calculator value on my calculator, so I'm just going to carry on using that. So I'm going to take the answer and I'm going to times it by 7.8, and that gives me 23,818. Again, I'm just going to round it off to the nearest unit. Question 10. Now we're told that the volume of a sphere is 4/3 pi r cubed, where r is the radius, and we've been given this diagram, which is a hemisphere, isn't it? A container is a hemisphere of radius 30 centimeters. So I'm just going to draw that on then. So here's the center of my sphere, and then the distance from the center to the edge in any given direction is going to be 30 centimeters. Okay. Right, so sand fills the container at the rate of 4,000 cubic centimeters per minute. So I'm putting sand in at 4,000 centimeters cubed per minute. Okay, so I suppose it's slowly filling up then, isn't it? So you're going to get sand kind of appearing in the bottom here, slowly filling up. Right, so does it take less than a quarter of an hour to fill the container? You must show your working. Okay, so I suppose what we need to do then is to find the total capacity of that hemisphere. How much sand will it hold altogether? And then we're going to have to compare that with the rate it's filling up at 4,000 cubic centimeters per minute, so we can work out then how long it would take to fill, and we can see then if that is more or less than 15 minutes. Okay, so let's do that. Let's work out the volume of the hemisphere then. So the volume of the hemisphere is going to be half of the volume of a sphere, which is, we were told, was 4/3 pi r cubed. Okay, what's a half times 4/3? That is just 4/6, isn't it? 1 times 4, 2 times 3, it's 4/6. 4/6 of pi times r. What were we told? R was 30, wasn't it? So it's going to be 30 cubed. Okay. So I suppose I need to work it out with the pi, don't I? So I'm going to have to type that into my calculator. I'm going to type 4/6 times 30 cubed times pi. Well, thank you, calculator. That's 18,000 pi, which is 56,548. Just going to write it down with pi in it in case I need to do some further calculation. And then I'll write it down as a decimal rounded off. So that's 56,548. Just going to round it off to 56,550, I think. 56,550. 4 significant figures at the moment, and I can drop down to 3 later perhaps. Okay, so that is the number of cubic centimeters that are inside that hemisphere. Okay, now we're told that it fills at the rate of 4,000 cubic centimeters per minute. So if I divide that number by 4,000, it should tell me the number of minutes it takes to fill. So time taken is going to be volume then divided by 4,000. Now I've written down the rounded off amount, but I'm just going to use the one that's still in my calculator. I'm going to divide that by 4,000 to retain accuracy. And I'm told now that is 14.137, which I'm going to round off to 3 significant figures, which is 14.1. So that is in what, minutes? Okay, so if we answered the question, what was the question? Does it take less than a quarter of an hour to fill the container? That was the question. So did it? Well, it took 14.1 minutes. Is 14.1 less than a quarter of an hour? Yes, it is. So the answer is yes. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.